Hey there, geometry. We are in Unit 2, Lesson 9. Trying to get my face in the right place. Today's lesson is coming from our kitchen. My dog is over there panting up a storm because she's been walked and ran a lot today already. And it's really hot out there. So, if you hear her, I apologize. Today we're going to be diving a bit into this, I'm not drawing yet, into this side-side-side triangle congruence theorem. And again, I've already talked about it a little bit, but we're going to go into it in more detail. So that just means that when you have two triangles, you know that one side's congruent to one side, another side's congruent to another side, and the third is congruent to the third. Then the triangles are congruent. You've proven it. Proved it? Proven it. Not sure. All right, so let's look at our warm-up. Construct a triangle with the given side lengths on tracing paper. We can't. I would love to say that we had some noodles, some spaghetti noodles in our classroom, these sizes, and we could put them together, but we don't. Here we are doing a little bit of video learning. So that's an amazing straight line. It would look a little bit like that, straighter, but a little bit like that. Actually, no, we're not going to do that. That's pretty close. Can you make a triangle that doesn't look like anybody else's? No. Everyone's triangles will look alike. Now, may the triangles be laid out different? May someone's look like this? Yeah, where it's just a reflection of that one. Or maybe someone's triangle will look like this. Yep, reflection. So they may be transformations of each other. But congruent. Because of side, side, side. Okay? All right, so now let's look here. Proving the side, side, side triangle congruence theorem. So our student task statement is, Priya was given this task to complete. Use a sequence of rigid motions to take STU onto GHJ. Given that segment ST is congruent to GH, so ST is congruent to GH, I'm marking the givens. Segment TU is congruent to segment GH, so TU is congruent to HJ, sorry. And segment SU is congruent to GJ. For each step, explain how you know that one or more vertices will line up. So let's change colors to try to make everything clear. I would do a translation and then a rotation and a reflection if I could. Let's see, if I take, I could pick any vertice. U to J, it's going to look a little like this. See if I can match it up a little bit. That'll be T prime, U prime, and S prime. All right, then I would change colors, rotate it until it looked like this. Let's see. A little bit like that, where that is U prime, T prime. Nope, that's not U prime. Sorry, you probably knew that. T prime, S prime, U prime. So I just rotated it, and then I would reflect it. Let's change colors. out of colors. I would reflect it. Oh, let's go back and make these double primes, right? Because it's another image. And then I reflect it, and I would get T triple prime, S triple prime, and U triple prime. All right, so 3 transformations, and I got my STU triangle to coincide with my GHI. I can't read the letters underneath there anymore. GHJ, sorry. GHJ triangle. All right, hold on. I'm going to pause for a second. I'm back. I had to answer another student's question, so where was I? All right. Use a sequence of, we did that. Explain how you know one or more vertices will line up, because we did a sequence of rigid motions. If all of the sides are congruent, I mean, we made it so that S triple prime, T triple prime lined up with GH, and it says right here that ST is congruent to GH. Oh, that was bad. So we know so the vertices should line up. And then we made it so that T triple prime, U triple prime lined up with HJ. And here it says that TU is congruent to HJ. All right, so we used that sequence of rigid motions to line up all the vertices so that the congruent segments coincided with the congruent segments. All right, so help her finish the missing steps in her proof. I'm going to make sure. That's weird. One second. Well, I hope I get them right. ST is the same length as GH. You could also say HG. It doesn't matter. So they're congruent. Therefore, there's a rigid motion that takes ST to GH. Yeah, same thing. GH or HG. It doesn't matter. Apply this rigid motion to triangle STU. The image of T will coincide with H, and the image of S will coincide with G. We cannot be sure that the image of U, which we will call U prime, coincides with J yet. But if it does, then our rigid motion takes STU to GHJ, providing that triangle STU is congruent to triangle GHJ. If it does not, then we continue as follows. Yeah, I don't like these proofs. I'd much rather do a column proof. HJ is congruent to the image of, let's look, HJ, S, or TU. Or you could say UT. No, you really should say TU because it's the right order. If we look at this statement right here, TU, HJ. So let's not do that because the letters need to be in the same order because those are the vertices that coincide. Because rigid motions preserve distance. Therefore, H is equidistant from U prime and J, yeah. A similar argument shows that G is equidistant from U prime and also J. So GH is the blank of the segment connecting U prime and J. It would say the perpendicular bisector, and I'll get to why in a second. Oh, if I could spell. Of the segment connecting U prime and J. Because the perpendicular bisector is determined by 2 points that are both equidistant from the endpoint of a segment. Okay? 1 second and we'll come back. I'm going to finish this and then we will. Reflection across the perpendicular bisector. I have to look at the picture over here in my book because I can't see the picture on the screen anymore. Of U prime J takes U prime to J. which it should because those coincide. So therefore, after the reflection, all three pairs of vertices coinciding, proving triangles GHJ and STU are congruent. Okay, pause for a second. Here we talked about perpendicular bisectors, and when I first went through my rigid transformations, I didn't use a perpendicular bisector. So let's see if we can do it again using a perpendicular bisector. I'm going back to, we just did rigid motion. We cannot be sure, proving. Okay, so I'm coming back here and I'm going to do big eraser. But you've got this already. You can always rewind and take notes if you want to remember the first way. All right, I'm going to pause it for a second. All right, I don't like how they did this one, but it's okay. So they say ST is the same length as GH, therefore there's a rigid motion that takes ST to GH. So let me change colors. And that just means I'm really drawing it as it's drawn at the end. I thought I changed colors. I'm drawing this as they drew it at the end of this little example. So there is a rigid motion that goes like that. We can say this is U prime, this is T prime, and this is S prime. Okay? Now, proving HJ is congruent to the image of TU. HJ, yep, image of TU, because rigid motions. Therefore, H is equidistant from U prime and J. So H is equidistant from U prime and J, which is true. Those are equal. And where am I? A similar argument shows that G is equidistant from U prime and J. Yep. True. GH is the perpendicular bisector of the segment connecting U prime and J. So let's draw that little segment. Okay, this is important to this lesson. So that's a perpendicular bisector of the segment connecting U prime and J. So it did perpendicular, and I can also say it bisects because they're equidistant. So really we're applying something we've already learned to this lesson. So GH is the perpendicular bisector. Yes, yes, yes. Reflection across a perpendicular bisector takes U prime to J. Yep. So we're reflecting U prime to J. Therefore, after reflection, all three coincide. Yep, they did it a different way than I did, which is great. And you could do it a third way that neither the book nor I did, and it would be great. It works. Again, I prefer column proofs. Now help Priya by finishing a few sentence summary for proof. To prove two triangles must be congruent. If all three pairs of corresponding sides are congruent, use congruence. Of segments to get a rigid motion so that two pairs of corresponding vertices coincide. If the third pair coincides, we are done. Okay? I'm going to use this really quick and write up a two-column proof. So activity synthesis. What we see here is HU Segment HU is congruent to segment HJ. Segment UG is congruent to segment JG, and segment HG is congruent to segment HG. And these are all given. This last one, it is given, but it can also be. And, all right. So everything's marked. I would mark this with a triple tick just because I like to. And now we can actually say that triangle HUG is congruent to triangle HJG because of side, 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 triangular congruence, triangle congruence theorem, right? So that's it. You prove that three sides are equal to three sides, side, side, side. Then you've proven the triangles are congruent. All right, what else do we know for sure about parallelograms? Okay, we've talked about parallelograms a few times already. So let's look at this one. Triangle, quadrilateral, ABCD is a parallelogram. So I'm going to mark it so. ABCD is a parallelogram, so we know that opposite sides are parallel and congruent. Opposite sides are parallel and congruent. Oh, I need double tick. By definition, that means segment AB is parallel to segment CD, and segment BC is also parallel to segment AD. We also proved that the sides are congruent. So let's prove angle B is congruent to angle D. B is congruent to D. So that's what we're looking for. I want to prove that. So I'm going to construct an auxiliary line, and my proof would look something like this. ABCD is a parallelogram. Given. So I can say AB is parallel to DC, and AD, sorry, that's really messy. AD is parallel to BC. Forgot my segment. And we could say the reason is definition of parallelogram. So we have given stuff and we're looking to prove stuff. So I'm going to construct diagonal AC. And now I can actually say that AC is congruent to AC because they are the same, because they're reflexive. And now I can actually say that triangle ABC is congruent to triangle CDA because of side, side, side. And at that point, we're essentially done. Angle B is congruent to angle D because of CPCTC. Congruent parts of congruent triangles are in fact congruent. All right, so there's my two-column proof with my statement and my reason. Okay. Work on your own to make a diagram, write a rough draft of proof with your partner, discuss each other's drafts, work together to devise your data. I think we're good. All right, so we constructed an auxiliary line, and we're good. Let me double check a few things. Yep, we got it. All right. Sorry, hold on. All right, what's important that I need to make sure you understand now, we've learned so much about parallelograms. We've learned that opposite sides are parallel. We've learned that opposite sides are congruent. And now we've learned that opposite angles are also congruent, right? So you've got that information in your head now or in your toolbox for stuff that you can use on future problems. And with that, I'll stop.